Hello, welcome back. My name is Cameron Kirk, and this is my series of tutorial videos on how to program in Verilog and program the DE-10 Nano board for developing hardware using a hardware description language. In today's video, we are going to actually write our first Verilog code, and we're going to sort of get familiar with how the syntax is and how we're going to actually make our different modules and things like that. We're going to do a simple AND gate, and then we'll do a couple of small twists just to sort of do a small introduction into writing Verilog code by hand. I feel like we've definitely reached the point where we can't go any further using the block diagrams just because of how much work it's going to be to actually wire things together. I've actually already tried making a video a little bit more advanced using the block diagram, and I ended up having to pull the plug on it because of how massive the block diagram became. And that's when I decided, okay, it's time to do some Verilog. So the other thing is I am going to actually use the Arduino headers on the DE-10 Nano board to make an LED light up as the output for our AND gate in our Verilog module. Feel free to continue to use the onboard LEDs if you don't know how to really work with building circuits. I'm going to be using a 220 ohm resistor and a simple red LED. I will show how to build the circuit and connect it, but I'm not going to go too much in depth on building circuits in this tutorial series, so just keep that in mind. It's going to be the same process. We're going to open up the schematics. We're going to find that pin code for the pin assignment and go ahead and add that location as the pin assignment. So it's the same drill as working with the onboard LEDs. I just wanted to mix things up a little bit in this video. So with that said, let's go ahead and dive right in. I'm going to create a new project here. I am also testing out new video settings for recording this video. So hopefully things come out okay. I noticed my computer just, my poor laptop wasn't quite handling the 1080p 60 FPS while also running, the compilation or creating a new project in Quartus. It's hitting my CPU a little bit too hard. So hopefully this video comes out pretty good at the end of it. So I'm going to put my project, as usual, in the DE-10 Nano Live Demos folder as soon as I can find that. Got my iced coffee here, ready to go. All right, yeah, this is video 6, but this is actually a failed video using the 7-segment. Tried to do a block diagram for a 7-segment display decoder, and it ended up being an insane amount of work. And 35 minutes in, I was like, all right, I don't expect any of my viewers to actually follow along with this. This is way too much, so it's time to learn some Verilog. Okay, so I got a folder named vid6 here. I'm going to select this folder. We're going to call this and to v _v. That looks good. We'll click next. Empty project, not adding anything. We need to select SE base, stretch this out a little bit, stretch this over. It's the U23i7, click next, nothing changes here, and click finish. Give that a minute to load. Okay, and we are back, and it looks like it finished creating the project. So we're gonna go up to File, we'll click New, and this time we will not be getting a block diagram. We are going to get a Verilog HDL file. Click OK. And we are ready to start typing. So just going to start writing some code, and you can start to see what it looks like. So we're going to write module, and this is where we're going to put our module name right here. Open and close, and then with a semicolon, come down here, and we have end module right there. And we have just declared a module with the name. Let's go ahead and change this to and. Let's call this my and. Oh, no. Let's call this the name of our top level entity in our project, and2v. That is important. So this needs to match. and2_v. Great. Now in here, so basically you can think of a module as like just sort of a black box, and in the parentheses we can describe sort of the wires that are coming in and out of this black box. And then obviously in between here, this is going to describe what's in that black box for how the things are connected inside. So I'm going to put Y as my output, and I'll do B as an input and A as an input. You can put the inputs and outputs names up here, but for simplicity, I will do it down here. So you have to specify that for the output, Y is an output. Similarly, for the input, we have B and A. All right. And the commenting is similar to C++ and C. We could do module input, and we could do a / and module output. We got little comments there. Great. And so now we're going to do an assignment. We're going to do a continuous assignment. So this means that all throughout runtime of our module, this assignment happens instantly, and it is continuously happening. So there is no sequence in which these things happen. If you have multiple assignment statements, they all happen together instantly. It just happens instantly. So there is no, it's not like Python. We're not going to do one line at a time. At runtime, this all happens concurrently. That is one fancy word you can say that describes what's happening here. So this is an assignment that happens concurrently or instantly. Yeah. All right, so we're going to say assign, and we're going to assign C, and we're going to do a logic statement here. So I'm going to do A and B. There we go. And we're done. So this is a continuous, oh my goodness, assignment. Yeah. Great. And then I like to put little spaces in front of these comments. So that doesn't really matter. So this looks good. Let's go ahead and save this. And we will leave the name the same. Save it. And we will go ahead and continue with our analysis and synthesis. This will tell us if we have any errors, anything we should be aware of. So as we do more videos, we'll start to see, we'll start to get more and more familiar with Verilog. But for now, let's just copy this code down and let's go with it. So I suppose, wow, this is, oh, no, it's done. Okay. So now if we jump into, let's do a waveform. Can never forget not to do the waveform. We right click, insert node or bus, node finder, list them all. There they all are. Those are our inputs and outputs as described in our Verilog code. We'll bring those in, click OK. I'm going to apply the counter, we'll do 100 nanoseconds to A. And we will do 200 nanoseconds to B. Click OK, hit the play button, save it. We'll say yes. Take a drink of coffee. There we go. This video is nice and easy. And I made a big mistake because our output name is Y and I put C. So let's switch back over to here. Y. And why I put C. We'll save that and we will start the analysis and synthesis again. And while this is going, let's quickly talk about, oh man, as soon as I do that, it's done. I think I'll wait because it's going to be quick, and then as soon as I say something, it finishes up that quick. All right. Oh, and I have 2 Quartuses open. Let me close one of those. All right, let's open our vector waveform again. Let's try that one more time. So in order to get to the vector waveform, I'm going to do all files. There is the waveform. Click open on that guy. And let's try this again. There we go. That's more like it. So instead of going through all the trouble of doing the pin assignments and uploading it to the board, I was able to find out that I did something wrong in my code using the vector waveform. So see, I was testing you. I put that mistake in there on purpose just to demonstrate how useful it is to quickly fire up the waveform and check it on there. Great. So before we do our pin assignments, let's build the circuit. So I mentioned I want to do the Arduino headers. Put the Verilog code up on the screen. And let me turn on the lamp and switch over to the tabletop. I guess I don't need the lamp. The lighting's fine. Okay, so here's our board. And I need a breadboard. So I'm going to rip this guy apart. I have a circuit already built. There it is. So on this breadboard, I have a 220 ohm resistor. And connected to that resistor, I'm going to take the long end of the LED and put it on the same row, and put the short leg on a different row, like that. So maybe it's better with the lamp off. Yeah, it is better with the lamp off. So the leg of the resistor is on the same row as the long leg of the LED, and the short leg is on a different row. Doesn't matter what order you do the circuit in. And then I'm going to take the short leg of the LED, the same row. I'm going to plug a jumper wire into the short leg of the LED, and I will connect that to ground on the Arduino header. So there is a spot that says GND on the Arduino header, and I'm going to plug into that, making sure I don't plug into the 9 volt that is right next to it. That is an accident waiting to happen. Great, and then I will take the end of the resistor, the same row as the other end of the resistor, and I'll plug in a jumper wire into the same row. And I'll plug that guy into the very first pin available on the Arduino header on this side of the board, the very top one. And that is going to be the very top one on the, let me read that, the JP3 header. And that's our LED circuit here. I'm still going to use these switches for my controls. And that's our circuit. We're good to go. So let's switch back over to the desktop and let's get our pin assignments going. To do our pin assignments, I'm going to hurry this along here because I think we pretty much know what's going to happen in this video. So I need to go to my DE-10 Nano, and I need to get I have it in here. I need to get the schematic out, the DE-10 Nano schematic. And what we are looking for is SW0 and SW1. I think that's on page 6. I think I'm getting good enough at this to where I just know where stuff is. And there they are. So SW0, Y24, W24. Let's go ahead and program that. So I'm going to go back over to Quartus. I'm going to go to Assignments, Pin Planner. Excuse me. Input Y24. W24. Let me just double check on that. Yes. I'm also going to change the I/O standard to 3.3 millivolts, or sorry, 3.3 volts. 3.3 volts. Now the output, this is going to be connected to the Arduino header. So in the schematic, this is one we have not looked at in a previous video. We need to figure out where the Arduino header is. And I'm going to flip through the pages here. I was just looking at this the other day. I think it's, oh, here it is. So on page number 3, we zoom in here. We have these Arduino I/O, but we don't really know what pins are the Arduino I/O, do we? So, well, I think I do know, but we need to flip down to the back, and I know this because at the very first page of the table of contents, it tells you what page the Arduino pins are on. But I'm going to flip back here without looking at that. And if I don't see it, then I'll... There it is. So on JP2, which one is pin 1? Which one is pin 0? Oh, pin 4 is... So on JP2, I think we want IO15. JP2. Oh, JP2. We want JP3, I'm pretty sure. JP5, yeah, we want JP3. So here's JP3 and pin 1. Okay, so that means, okay, so I'm looking at this here. This is the Arduino pinout. This is where things are oriented. I know this Arduino, on the Arduino, this is always going to be our 5 volt, 3.3 volt ground. All that, that's our power section. This is the analog to digital converter section. And then these are all of our digital I/O PWM pins. And if the board's oriented like this, and this is our guy, and then this top one's pin 1, then that means we plugged into pin 8 on JP3. And let me just verify that visually. Yes, JP3, we're plugged into pin 8. So pin 8, let me zoom in on this and make sure it's shown in the video. So I'm looking over here, and we're looking at pin 8, which is IO0. Okay, so I was looking at the right thing. So now what I'm going to do is I'm going to flip the pages back up to where I was. That had all the Arduino. There it is, and we're looking for IO0. IO0. So that's AG13. So let's give this a try. This is my first time trying to do this, so I think it will be exciting to see it work. So AG13 and 3.3V LVTTL, that updates automatically, so we can just close that. We can close the schematic. We're done with that. And let's start the compilation. And I will pause the video and we will return after it is done compiling. Okay, we are back and it is all finished compiling. Let's switch over to the tabletop and we will go ahead and supply power to the board. Great. And then let's go ahead and plug in our USB cable into the USB blaster. Great. And while we are here, let's just take our wire. We know we're going to plug into that bottom one on the GP3. Let's bring it over to the 5V and see if we can get, oh, yep, the LED is lighting up. So that is a great way to check if you've wired your LED correctly. Sometimes you can plug it in backwards, or maybe you have a dead LED. This is one way to test. So all I'm doing is plugging into the 5V on this Arduino header over here. It's labeled on the board. Great, plug it back over here. Let's switch back over to Quartus. And we did our pin assignments, we compiled, we are ready to program. So we're going to go to Tools, we're going to go to Programmer, and we are going to make sure that DE-SoC is selected under the hardware setup. Click it right here, close it. We are going to click Auto Detect, and we want to leave this default. Click OK, say yes. Now we need to select a file for the 5CSEBA6. Double click on None. Go to Output Files to select your and2VSOF or whatever you named your project. Check the box for Program Configure and click Start. It says 100% successful. That is excellent news. Let's switch over to the tabletop and see if this thing works. So we did a simple AND gate. Let's see what we get. So if I do the first switch SW0, let me get a wire here. I love wires for pointing. So I did SW0 there, and I flipped it on, but the LED did not light. If I do SW0 and SW1, our LED lights up, as we can see right here. That is great. And then if I flip down SW0, so it is off, it stops working. The LED turns off. Great. So I think we are all done. I think in the next video I will do some variations on this AND gate, but let's stop here. Let's cut this one a little bit short. This one was easy today, and we'll pick it up next time. So thank you so much for watching, and I'll see you in the next one. Take care. Bye-bye.